Okay, great. So thank you so much for having me come here to share with the student club about career aspects in quantum and technology in general. I hope to leave maybe a few minutes at the end to answer questions. If we run out of time, don't worry, feel free to reach out to me on LinkedIn. So I am Kitty Yeung. I'm a physicist and an artist. I will walk you through a journey forging a path in science, engineering, as well as design and art, and why are all these things needed. I spent the last 16 years in academic research and industry technology development. It has been a journey of continuous learning, problem solving, and mindset shift. It helped me realize that to pursue a dream and to take on larger responsibilities for our society, just doing science is not enough. Recently, I officially began my startup journey inside Microsoft. I'm leading an incubation team to explore new world businesses for the company. Since our focus for today is exploring quantum computing, we'll start from there. Before I started my current incubation, I was a quantum computing architect. At Microsoft Quantum, my job was to help design the full stack architecture for our quantum machine, integrating all layers of the quantum machine from the hardware to the software. By using my knowledge in condensed matter physics and my skills in the arts, I put together materials to explain to our different parts of the team how the stacks work together. Because to build a quantum computer involves many areas of expertise, I effectively functioned as a translator and a science communicator between the technical engineering teams and business teams to facilitate understanding and decision-making. I also did a lot of teaching and produced education materials. I manage a small team of content writers. In fact, some of them were actually physics students from ETH Zurich. They're working with me to create the Microsoft Quantum Learning website and the MS Learn modules some of you may be using today. If you haven't used them already, definitely check them out. These can help you directly get started with learning in industry tools such as Azure Quantum and the quantum language Q#. I know my colleague Matthias will be giving you some related materials in his talk next. During my work, teaching both internally inside the company and to the public, the number one question that I get is, how do I get into quantum computing? Mostly by people who are working in different fields already in the industry, or students exploring job opportunities. This slide here is kind of giving you the answer, but I will be more specific and answer this question in a little bit. But before I do that, perhaps we should take a look at what prompted that question. We know that quantum computing is utilizing concepts in quantum mechanics to construct a new way of computation that can be more efficient than classical computing for certain problems. After the possibility was proposed about 2 decades ago, in the last few years, the industry has pushed the field forward drastically. And that was also when we heard a lot of hypes. Many people want to get into quantum computing, but let's remind ourselves, that's not why we chose to do science and technology. What made us scientists and engineers is the love of nature. The beautiful things that inspired us and enlightened us when we were little. Is the intellectual drive to explore, to apply what we learn into helping others. I always remember this feeling of a child inside me gazing the stars, being drawn into the universe. Perhaps some of you, or like me in the audience, at some point wanted to be an astronomer. Or you may practice music and you want to be a musician. Or you love art and have other interests. I did all of these things, and I still do. I also were interested in philosophy, fashion design, and all kinds of intellectual fields. My family fully supported my interests and aspirations and provided some guidance. They said no matter what you do in the future, a good human being should make a positive contribution to the society. That sounds a little grand for a child, but that was what guided me. It became a lifelong guide. At a young age, I started searching, how should I make a positive contribution? What job should I do to achieve that? When I started learning physics in middle school, I fell in love with it. It is a subject that studies nature. Nature creates the most beautiful art. We learn how nature works and then engineer things that can help people and the environment. I thought becoming a scientist, in my particular case being a physicist, could make the most direct contribution to the society in a positive way. If I pursue science professionally, I could still do art on the side. But if I pursued art full time, I could not have the opportunity to do science professionally. So my mind was then set. I needed to learn as much as possible and work hard to receive the best education in physics as I could. I was fortunate to be admitted into University of Cambridge for my undergraduate study in physics. That's where my professional career began. I learned in the Cavendish lab how condensed matter physics experimental research is done. I learned how to study the quantum properties of materials and build our fundamental understanding of nature. I also learned to build parts of the dilution refrigerators to do the research. I wanted to apply my knowledge in practical fields, so then I went to Harvard to pursue my PhD in applied physics. There, I designed circuits and chips to engineer plasmonic waves for computation and communication applications. And I went to the clean room to fabricate those nanometer and micrometer size structures that I designed. Because my PhD work on plasmonic circuits equipped me with skills transferable for making photonic chips. Upon graduation, my first job was at Intel Silicon Photonics. I worked on making photonic chips for data centers for optical communication. I designed on-chip lasers and components that were then fabricated onto wafers, which were cut into chips and put into transceivers, as you can see here, which were then plugged into the servers so that the servers can talk to each other and communicate through the optical fibers. That's when I realized, more importantly, in industry, we learn things that we don't really learn in academia. Industry is about turning our inventions in the labs to scale into products that millions of people in the world are using. And that is much more difficult and more complex than academic research and involves many aspects that we scientists and engineers were not trained to do in our formal education. And many of us may not at first like to do. When I joined Microsoft, those were exactly the areas I was tackling. How do we move technologies to real developments beyond the initial research, prototyping, and hype? What are the gaps in the industry that need to be filled? Are the technologies really solving problems that people need to solve? As you saw just now, even though I did condensed matter physics and studied the quantum properties of materials, I didn't do quantum computing. I wanted to see through the hype and needed to educate myself how quantum computing works and where the industry was at. After learning the fundamentals, I quickly found that many of our colleagues in other fields were also intellectually interested in the subjects, but didn't know where to start. So I started to teach. That was even before I joined the quantum team. I was managing the Bay Area Garage and Innovation Program at Microsoft. That was in 2018 and 2019. And we now know that during that time, education was really needed for more people to understand quantum computing. And I think still it is the case. Knowledge and accurate science communication have been a gap in the quantum computing industry. But the good news is that one doesn't need to do very deep quantum mechanics to learn it. There are three key concepts: superposition, interference, and entanglement. And with a little bit of linear algebra and a programming language like Q#, can get you hands-on pretty quickly with writing algorithms that can run on quantum hardware hosted on the cloud, for example, on Azure Quantum that Microsoft offers. I took the initiative to fill the gap and also started drawing comics to explain the scientific concepts and algorithms. I love getting feedback from my readers who describe my comics as intuitive without dumbing it down. The content was very well received as I taught the quantum computing classes for communities, even outside Microsoft, joining from all kinds of backgrounds. In 2020, every Sunday from March to November, I was given a class at Hackaday U and producing a new page of the comics I post online. These efforts were even outside my day job. It was a lot of work, but I accumulated so much materials that was even enough to publish a book, a quantum computing and some physics illustrated. Teaching was also a great learning experience for me, scientifically by expressing concepts in drawings, words, and equations that helped me really understand what I was talking about. The teaching experience also helped me understand what people needed. We all have different backgrounds, interests, and needs. There's no one size fits all that one size fits all quantum computing learning materials. To push quantum computing forward, there are many kinds of talents the workforce needs. People who write algorithms, people who build the hardware, people who communicate or apply quantum computing in their industries as early users. You can become any of them, depending on what you are passionate about doing. With all that experience I gained from my side projects, by talking to real people, it informed me what to build at Microsoft. I produce learning materials that are geared towards people's interests, goals, and current understanding of quantum mechanics and maths. We offer a wide range of information from fundamental learning to industry case studies. For a while, we had a recommendation tool of materials best fit for each person. So now for you to get into quantum computing industry, you have all the materials out there to use. The best way for a student to have a good grasp of where the industry is at is to try these tools hands-on. We have Q# and the Quantum Development Kit that are open source with documentation. And there's Azure Quantum, the cloud service that is available for you to try running your algorithms on hardware. Just from a job opportunity perspective, imagine you contribute to open source projects that the companies put out there on GitHub. That can be on your resume. When you apply for a job, the engineers in those companies then recognize your GitHub name and contributions. They would love you to join their teams. That's how I got each of my dream job, by already doing the job before it even existed, because the industry needs it. When you do that, the job may be created just for you. You may have noticed that even though I used my experience as an example of a career track, I hardly talked about the so-called career. I said nothing about job titles or salary because it is about the jobs to be done. Finding the gaps in an industry and taking an initiative to fill the gaps reflects your passion for the subject can lead you to where you want to be. For any new technologies to develop and deploy at scale, it may take 10 to 20 years after a prototype is made in the lab. This year is 2022. We know there are still a lot of gaps in quantum computing and lots of opportunities for you. We need to develop quantum hardware and need more algorithms that can take advantage of the promised power of quantum computing. The promised power of quantum computing may allow us to solve some of the hardest problems on the planet, such as clean water, clean energy, fighting climate change, etc. That's why you chose science and engineering. That's why you are drawn in the quantum industry, not because of a hype, but because you can apply your skills and knowledge to help the world reach these global goals one step at a time. If some sort of structure helps you, many people like to think of career growth like some kind of a pyramid or hierarchy of titles, but really it is not. It's about continuous learning and professional maturity. At the beginning level, you are developing personal growth on an existing platform. Like you are studying in a school, in a university, getting a degree, getting your first job, all for yourself. Then you are ready to produce what other people need to help them. You continue to contribute more and more for more people, and eventually create a platform with a healthy culture for others to learn, grow, and contribute. Once you do that, you find also yourself aligning your passion and what you do with what the world needs. Our career choice should let us reach our maximum potential with our passion, mission, what we do well, and the global goals all aligned, not measured by some artificial, superficial metrics. I also want to acknowledge that I came to this realization not purely through doing science, but by also doing art at the same time. You have seen that I created comics to explain quantum computing. That was only one manifestation of my combined passion. In fact, I have been keeping my artistic track going. At first, those were hobbies for me to relax after a day of scientific work. But gradually, I found ways to combine technologies with my artistic expression through fashion design. I have made wearable designs that embedded all kinds of functionalities into clothing and contributed back to the maker community by making my projects open source. But discovered also there are huge gaps between making these handmade prototypes to be reproducible products. And most people don't even know these technologies existed. Intellectually intrigued, I started building a fashion brand to tackle those technical difficulties in scaling, while I continue to work on hardcore science and engineering, photonics, and quantum computing. I wanted to add a bit of different color to the tech world with a tech fashion brand called Art by Physicists, creating STEAM and sustainable fashion with digital painting and printing, open source hardware, 3D printing, and physics simulations. I learned so much by building a creative brand, using technologies to do science, to do design, making manufacturing processes open source for education, and donating profits generated from these products to STEAM and environmental protection nonprofits, and promoting an intellectual representation of women. The same methodologies that I learned in doing photonics and quantum computing for scaling apply. But is scaling always leading to good outcomes? We produce in order to solve problems or address needs to help more people. But some industries have so large of a scale that they no longer support creativity and innovation. For example, the established supply chains are built to support mass production of goods people don't even want that end up in landfills and incinerators. In this case, for what I discovered, that fashion industry is one of the largest polluters in the world. What we may perceive as the beautiful, the glamorous on the surface is deep down supported by some of the ugliest truth in our world. How is this even allowed? Could it be that people working in the artistic fields are left out of the development of technologies? Could it be that people working in the STEM fields not caring enough about the arts? Could it be the mindless pursuit of profits made people forget their responsibilities to protect the planet? I think it is especially appropriate to emphasize this today as it is Earth Day. It was heartbreaking for me to find out the contradicting nature of our world. And there are forces out there that are breaking the world apart as we see today, that are affecting our society negatively. But within the realm of our abilities, every one of us should be empowered to change the status quo, aligning our passion, mission, and what we do with the global goals to solve some of the global problems yet to be solved. Coming from the scientific background with semiconductor manufacturing experience, I couldn't help but wonder if we can apply some of the methodologies in making technology products to help the fashion industry be more efficient, reduce waste and pollution, and support creativity. This is what I'm setting out to build now. For me, the artistic track is no longer just a hobby. There is a bigger mission. And that's why I decided to start a new business to solve an urgent problem that happens to be within the realm of my abilities by combining the two tracks. If I didn't have this other track, I would just continue to do what I was doing before. But now, since I discovered a problem that I can uniquely help solve, I cannot just let it pass. This is also why I did not do a startup right after I graduated and didn't do that when a technology is at its hype. Although the fashion industry cannot leverage quantum computing just yet, my learning in all the past areas is important. By using technologies to help a traditional industry, there are long-term implications in education, workforce enablement, and economic shifts. My advice to you is to not silo yourselves, have empathy and understand other people. Make decisions that solve big problems. How do you maximize your support for others rather than being fixated on your own career? Pursue your passion, even if it is not your current job. I would not have found out about problems in the traditional industry if I just did science and tech. At its core, many of the problems we have today are caused by the silos between the fields. People not communicating, people not understanding each other. Doing STEAM let me pursue a journey of turning creativity into meaningful productivity. Only by linking the different areas together can we make the world a better, a happier, and more beautiful. I hope what I shared today could be helpful for you for future career choice. Thank you.